Welcome to the Deep Dive. Today we're plunging into a topic that's evolving at what feels like, well, quantum speed AI and software development. It's not just about language models suggesting variables anymore, is it? We're seeing them commit full features.
Yeah, entire pull requests rolling in from machines. It's kind of mind-blowing when you think about it.
It really is. And this rapid evolution has, CTOs, founders, developers everywhere asking one core question. What's actually the best AI for coding in 2025? And maybe more importantly, how do we integrate it day to day?
You've hit on a critical point there. Just a couple of years ago when we talked about AI and code, it was mostly like advanced autocomplete.
Mm,
Now, like you said, machines are delivering complete PRs. And the source material for our deep dive today is really clear on this. You can't answer this question with just social media hot takes. You need cold, hard numbers.
And that's exactly what we're aiming for today. Our deep dive is built around AI Coding Champion 2025, Benchmark Results and Analysis by ASMAT, published just recently, June 20, 2025. Our mission really is to map the current landscape of these AI coding models using rigorous, objective benchmarks. We want to help you cut through all the marketing noise and really understand which AI is the best fit for your coding needs.
It feels like a pivotal moment, doesn't it? 2025, it feels like a new era for these benchmarks. They've matured quite a bit. Vendors have opened up their APIs, which is huge. And engineers are now testing these models the way we test microservices. You can
Yeah.
push them until they break.
Yeah, just hammer them.
It's become a genuine data race for performance.
And that data race, it's not just some academic exercise, right?
Yeah.
It has tangible, real-world impact. The source highlights how LLM benchmark leaderboards are now directly influencing quarterly budgets. That's serious.
Oh, absolutely. And we're seeing recruiters, sliding screenshots of these leaderboards into job pitches. Yeah. And DevRel teams, they celebrate a top 5 finish like it's a major product launch.
Wow.
The author even points out that the phrase best AI for coding 2025 probably appears in investor decks more often than cloud margin these days.
That says a lot. It's serious business. So, okay, when we talk about where these models are truly put to the test, the source points to two key battlegrounds, LiveCodeBench and SWE-bench. Think of them as like high-stakes stress tests. They tracked accuracy, sure, but also critical stuff like latency and, crucially, the dollars burned per request.
Precisely. And they each reveal different facets of a model's coding ability, sort of mirroring distinct types of development work.
Okay, let's dig into LiveCodeBench first.
Yeah.
The source describes it as the gym where language models lift algorithmic weights. Sounds intense. It's packed with over 1,000 problems from competitive programming sites, LeetCode, ActCoder, Codeforces. And the key thing seems to be hidden tests to prevent cheating or overfitting.
Right. And when you look at LiveCodeBench, it's tempting to just, glance at the top accuracy number. Like, okay, OpenAI's O4 Mini leads at 66.5%. But the real insight here, maybe the ugly truth as the source puts it, is that top-line accuracy can be a bit of a mirage.
How so?
Well, the real story is in how a model performs across price, latency, and, critically, how it handles those hard problems. Lots of models can breeze through the easy stuff, but then they just stall when, say, recursion meets dynamic programming.
Oh, okay. The tricky stuff.
Exactly. So the best AI for coding 2025 isn't just about that one number. It depends on how deep your backlog of complex problems goes. Like, for instance, O4 Mini gets that 66.5%, costs around $1.10, $4.40 out, latency about 33 seconds. Pretty good. But then you have OpenAI's O3, 63.2% accuracy, but double the cost, double the latency at 64 seconds. Or Anthropic's Claude Opus 4, the thinking version, 63.1%, similar accuracy, but look at the cost. $15 in, $75 out, and 93 seconds latency.
Oh, okay. Big difference.
And Google's Gemini 2.5 Pro preview, 61.9% accuracy, reasonable cost at $1.25 in, $10 out, but much slower at 165 seconds latency.
So lots of trade-offs there, even at the top.
It's a huge trade-off.
That's a great deep dive into LiveCodeBench. It really exposes that algorithmic side. But like you said, not all coding is neat puzzles. Let's talk about SWE-bench. This one sounds like it throws models into the methy reality of actual GitHub issues.
Exactly right. SWE-bench swaps those, let's say, pristine algorithmic puzzles for actual GitHub issues, complete with their own directory trees, test harnesses, and all those delightful unknown landmines developers hit every day.
Delightful.
The key thing here is an agent wrapper. It lets these models actually open files, run bash commands, edit code, push patches, basically try things until the tests turn green, or as the source nicely puts it, until patience evaporates.
Oh, I think every developer who's stared at a failing CI pipeline could feel that one. Brutal, but realistic. So who does well in this chaos?
Well, looking closer here, the crown actually sits on Anthropic's Claude Sonnet 4, the non-thinking version, at 65%. Then you have OpenAI's O3, and then OpenAI's GPT 4.1.
Interesting. Claude takes the lead there.
Yeah, and what's surprising are the different cost stories again. GPT 4.1 charges, like pocket change for pretty decent wins, whereas a 4 Mini, which led on LiveCodeBench, here it spends big compute dollars basically trying to brute force search its way through.
Brute force versus elegance.
Kind of, yeah. And latency here can really stretch out. We're talking minutes. The source mentions a 976-second wall clock time for some tasks.
Oof. Nearly 10 minutes. If your CI fires on every commit, that's problematic.
It's definitely something you need to consider. But that same brute force approach, sometimes it can patch bugs that the more, let's say, elegant models miss. So there's probably room on the team roster for both styles, you know.
Makes sense.
And it raises a key question for you. If you're working with, say, a legacy monolith with flaky tests, the source suggests you'll probably want Claude Sonnet 4 if you can afford the wait time. Otherwise, maybe pair GPT 4.1 with stricter static analysis and sleep well.
That's fascinating. So it's not just raw power, but the style of problem solving matters too. It's tempting to just grab the top accuracy number, isn't it? But clearly you'd be missing the bigger picture. You really have to read the fine print.
Absolutely. And cost. Cost can just explode if a chat loop spills tokens unexpectedly. The sweet spot seems to be models that price gate context windows rather than just charging per token on the output side.
Right.
And let's be honest, latency absolutely kills your flow state. Think about it. A 30-second answer feels instant, keeps you right there, but a 300-second answer, 5 minutes, that feels like your build server just, I don't know, went out for coffee.
Yeah, totally breaks the concentration. And for those listening who are, meticulously watching their budget, the source points out a really compelling option. Google's Gemini 2.5 Flash Preview, it manages, 35.6% on SWE-bench for just 11 cents a test.
11 cents.
That's basically, as the source calls it, the best AI for coding-free slice of 2025. Pretty amazing value.
It is. And a key takeaway here is the bottom line. There's no trophy for burning through pay-as-you-go credits faster than anyone else. Balance sheets ultimately decide the long-term champions in this game.
Okay, so let's try and pull all this data together. The source provides a consolidated benchmark view, which is super helpful. It cuts through all those, endless Reddit arguments and just hammers home the reality.
Yeah.
You have to match the tool to the problem. There's no single best.
Couldn't agree more. Let's quickly connect this to the bigger picture, looking at the main players based on those consolidated numbers. Okay, so OpenAI's A4 Mini, great on LiveCodeBench, 66.5%, less so on SWE-bench, 33.4%. Latency's good at 33s, costs around $1.10.
Right, the algorithm whiz.
Then OpenAI's O3, pretty balanced, 63.2% LiveCodeBench, nearly 50% on SWE-bench. 64's latency, $2 cost. A solid all-rounder, maybe?
Okay.
Anthropic's Claude Sonnet 4, non-thinking. The SWE-bench king at 65%, decent 63.1% on LiveCodeBench, but slower, 94s, and pricier, $15.
The bug hunter for tough project.
You got it. OpenAI's GPT 4.1, consistent 47.4% on both, but slow at 174 is the big win. Cost is super low, just $C$0.45.
Budget champion, if you can wait.
Exactly. Google's Gemini 2.5 Pro, good scores, 61.9% LiveCodeBench, 46.8% LiveCodeBench. Latency 165s, cost $1.25, another strong contender. And Google's Gemini 2.5 Flash.
All right.
No LiveCodeBench data here, but 35.6% on SWE-bench. Slowest at 252s, but that costs you 11 cents. Just incredible value.
Wow. Okay. Seeing it laid out like that really clarifies things.
Yeah. So for you, the listener, what does this mean in practice? Need quick pseudocode for like a tricky Codeforces D problem? OpenAI's O3 Mini probably serves it hot and fast. Refactoring a really tangled Java service or wrestling with legacy code. Anthropic's Claude, with its calm, structured responses, tends to win there. Building documentation from thousands of lines of existing comments. Google's Gemini, with its huge context window, that's where it really shines.
So that adaptive mindset, understanding that the best AI for coding 2025 isn't some static title, that's the key takeaway here. It really travels, doesn't it?
Absolutely. It's context dependent.
So with all this fantastic data, how do you, our listener, actually go about picking the best AI for your specific team or project? Let's bring this home.
Right. Well, The source actually provides some tailored recommendations, which are quite helpful. For the solo hacker, maybe building side projects, you want speed, minimal cost, answers that fit on your screen.
Hmm.
The source suggests OpenAI's GPT 4.1 Mini or O3 Mini. They'll feel like a friendly rubber duck that just happens to know regular expressions really well. Add a local lint step, ship it.
Simple and effective.
Now, if you're a startup, maybe with a growing code base, latency matters, sure, but breaking production hurts way more. The recommendation is to maybe mix OpenAI's O4 Mini for things like test scaffolding with Anthropic's Claude Sonnet 4 for those really deep bug hunts. And definitely keep a close eye on those LLM benchmark leaderboards. 2 months in this space, that can completely flip the winners.
Good point. Constant vigilance. What about enterprise?
Yeah, enterprise with serious security reviews, audit trails, reproducibility, context windows big enough to swallow entire monorepos. Those become critical. Google's Gemini 2.5 Pro, especially if you pair it with an internal diff viewer, apparently really earns its keep there. Just make sure you tie requests to internal approval flows. Otherwise, you risk rogue patches landing at 3 a.m. Nobody wants that.
Definitely not. Okay, one more scenario.
Right, the budget-constrained open-source maintainer. Here, cost is everything, right? Google's Gemini 2.5 Flash preview is pretty much crowned the best AI for coding free crowd. Look, it won't ace every single task, but it gets the pull request started. Volunteers can then finish off the edge cases. It's about momentum.
That makes perfect sense. What stands out to me across all of these is that every scenario, however different, leans on the same foundation. That objective benchmark data, the best AI for coding 2025 for one sprint, really might fall to 5th place after a server upgrade or, a new model drops.
Yeah.
So the clear message is, watch the numbers, not just the hype.
Precisely. And what's really compelling is how the benchmarks themselves are evolving, too. It's not static. LiveCodeBench is planning agent modes, letting models spawn subtasks, and SWE-bench, well, it already lets agents crawl directories, grep for stuff, compile code.
So it's moving beyond just single-shot code generation.
Way beyond.
The source talks about the next leap being autonomous orchestration, models calling shell commands, running unit tests, maybe even submitting their own merge requests independently.
That's the direction things seem to be heading, which raises the question, what new metrics will future benchmarks need to track? We're looking at things like multi-step problem solving, measuring planning and persistence, function calling, scoring how well they use APIs, and tool integration, grading how gracefully a model flips between talking to you and using external code tools. Once these tests mature, I suspect agent reliability will become just as important as raw accuracy is today.
Fascinating stuff. Okay, to wrap things up, the source offers some incredibly practical nuggets, almost like a field guide to fast failures and quiet victories, things developers can use right now. First up, fail fast. If a model loops more than, say, 5 times on a LiveCodeBench task, just cancel it. Drop down a complexity level. Success usually comes early or not at all.
Good tip. Next, cache everything. Store conversation context, maybe in a vector database. It apparently slashes costs when models keep asking for the same file headers or context over and over. Smart. And this one seems critical. Guardrails beat accuracy. Static analyzers, linters, minimal privilege sandboxes. They're essential. They stop half-baked code getting into production. Even the absolute best AI for coding in 2025 needs a seatbelt, right? And you, the developer, you're installing it.
Absolutely vital. Another practical one, read latency like weather. Expect weekend spikes when global hackathons go live or usage peaks. Maybe queue less critical workloads for weekday mornings in your region. Save some costs, get better throughput.
That's clever. And finally, celebrate small wins. A simple 2-line patch that prevents an outage. That's worth way more than some massive 5,000 token essay nobody ever reviews or merges. Focus on real impact.
Hear, hear. Impact over volume.
So after this really comprehensive deep dive, the big question remains, who is the real coding champion of 2025? The source asks that exact question and then reveals the answer. It's a trick question. Haha, I agree entirely. It has to be a trick question. The crown just keeps sliding around because research doesn't pause for breath. And let's face it, enterprise budgets absolutely love surprises, both good and bad.
So where do things stand right now?
Well, to summarize the current snapshot, today, OpenAI's O4 Mini seems to rule LiveCodeBench. Anthropic's Claude Sonnet 4 dominates SWE-bench. And OpenAI's GPT 4.1 kind of owns the speed for cost category. But tomorrow, a fresh model checkpoint, an unexpected research breakthrough, it could reorder the entire stack.
So for you listening right now, the key takeaway really is, stay curious. Keep a close eye on those LLM coding leaderboards. And most importantly, benchmark these tools against your own specific workflows, your own code, your own problems.
Because ultimately, as the source so perfectly puts it, the real mantra for modern development is this: the best AI for coding 2025 is the one that ships your feature before the sprint review ends. That's the bottom line.